Hi, today I'm doing Chapter 3A homework, and looks like I came in through and answered some of these, but I don't know why or what I did, so let's try this again. In an editorial, the Poughkeepsie Journal printed this statement: the median price, the price exactly in between the highest and the lowest. Does this statement correctly describe the mean? No. The price exactly between the lowest and the highest is the mid-range. That's not the mean. The median. The median is if you line it up from least to greatest and then look at the value in the middle. It's not exactly the same distance from the top and the bottom. Like if you had 1 was your highest and 100 was your, 1 was your lowest and 100 was your highest, the mid-range would be, the middle. But the median, like at 50, but the median could be 20. It depends on what number. Like you could have 1, 1, 1, 1, 1, 5, 5, 5, 5, 5. So it's not the price that's exactly between the lowest and highest. It's in the center of the data. So no, I think it describes the mid-range, but not the median. Okay. All right, listed below are the top 10 annual salaries of TV personalities. Find the mean, median, mode, mid-range for the given sample. Given that these are the top 10 salaries, do we know anything about the salaries of TV personalities in general? Okay, so, and then are such top 10 lists valuable for gaining insight into the larger population? So let's just answer this second 2 questions, and then we'll go over and I'll show you how to do the first ones. When you're given the top 10 salaries of a group, obviously that doesn't really represent the whole group, because there's people that are in TV that are still working a second job making coffee, right? So we can't look at, Judge Judy, who's making $40 million a year or whatever, and average her in and say that's what people make when you work on television. That's what draws people to those careers, because people talk about those big salary people, but most people aren't making that. And so, no, it's not really that valuable, because it doesn't tell us about the larger population. It's the sample is skewed to be something that's not really that true. Okay, so let's take a look at how to find the mean, median, mode, and mid-range for these problems. The mean is the average. The median is the center number after it's lined up from least to greatest. The mode is the most frequently occurring, and the mid-range then is that value that's in between the highest and the lowest. So I have a different set of data, but let's see. Where's my data? Okay. Still number 2. Here's my data: 37.4, 36.3, 34.9, and so forth. So I'm using the TI-36X Pro, and I'll show you how to enter this data on the TI-84 if you have one. But the truth is, this calculator will work just fine. It's much cheaper, and anyways, so I go for this calculator. I'm not going to keep showing you how to do it for 2 different calculators, because it's just time intensive, and you can always Google how to do it on your calculator. Okay, so I'm going to clear this on clear twice. Press the on button, hit clear twice, it clears your memory. Then I'm going to hit data, and I'm going to enter this data. 37.4, remember you drop down with your arrow, or you could come down and hit enter. Both of those would do the same thing. 36.3, 34.9, I'll switch back and forth to show you that it doesn't matter. 16, 37, or 13.7, 12.1, 9.9, 8.7, and 8.8. Let's say that right about now you realize that the next to last one wasn't correct. You go back up to that and hit enter, and you could just type over it like, oh, that should have been 9.2. Or in this case, I want to go back and do 8.7. But you can always change one in the middle, go back and just type over it. And also you can delete one if you decided, oh, I don't want, I shouldn't have entered that one at all. I can go to that and just hit delete and get rid of it, right? But I want that one. So you can always delete or type over it to change it. That's on both calculators, but you have to hit delete on the 84 to get rid of something, and you can just type over it to change it. Okay, so I think I have my values correct. And now if I have that, I'm going to go to second function data, and that's going to give me my chance to do these statistical evaluations. If I go down to number 2, which is one variable stats, remember I have my data in L1, and then I'm going to hit enter because that's good. And I just have one of each of these that I'm interested in. I'm not doing like several. And then I hit calculate, and it tells me that I had 10 things, 10 pieces of data things, and that my mean X bar was 20.57. So for the mean for mine is 20.57. And then the median is down lower. Remember, you have to go down a ways. There's the median, 14.85. And then, what else did they ask for? The mode is the one that occurs most frequently. And if you look at our data, nothing came up more than once, so there's no mode. And the mid-range is just the middle between those two. So you take your highest value, which for us, it wasn't, 37.4 minus the lowest value, which was 8.7, and that gave me my mid-range. So that's not something you get on there. But you can see what your highest value was. Your minimum value, X, is given on your calculator here, 8.7. And then your maximum is given also, whoops, and the maximum was 37.4. So you're just subtracting that maximum and minimum to get that. And then I just would say that I already kind of answered that other question about, yeah, it wasn't that helpful because those don't tell us much of anything when we just look at those top-notch ones. So we're more interested in taking a sample that reflects the actual population. Okay, this one says the head injury measurements from small cars were tested in crashes. These are the HIC measurements, which is the head injury criterion. The listed values corresponds to A through G, find mean, median, mid-range, and mode, and complete parts E through F. Oh, for heaven's sakes. I don't know what part E through F is, but I'm not going to show you again how to find mean, median, mode, mid-range, because once you know how to do that, you do it. So, but I don't know what the rest of the questions are unless I flip over here. So let's look at mine and see what they're asking after that. Again, put your data in and then go through the same process to find those values. So we go, oh, that's what I wanted, was this. Okay, so we go through, here was mine, I don't know, mean, median, mode, mid-range, blah, blah, blah. And then it says, which car appears to be the safest? Well, you know, you want the car that's got the lowest HIC rating. I mean, the head injury criterion is the lower it is, the safer the car. So the car that's got, these correspond to A, B, C, D, E, F, G. So then I would say, okay, which one of those is lowest? It looks like 329. Looks like A is the best, safest car. Okay, and then the next thing they ask is, based on these limited results, do small cars appear to have the same risk of head injury in a crash? And the data, these are all small cars, but the data varies a lot. So I would say no, it doesn't really show that because they differ quite a bit. Look at the numbers that we had there. We had everything from 329 up to 541. So these are all small cars and they all sort of tested differently. So that's just common sense type of question that they're asking me there. Okay, So let's see what they're wanting for number 4, since it's probably a lot of the same. Yes, I'm giving you the same things kind of over and over. That's just so you get it in your brain how to do it, and then when you're on the test, you know how to use your calculator effectively. Oh, I didn't show you how to do it on the other calculator. Let me grab that. If you want to enter data in a TI-84, you go to Stat, go to Stat, and then you go to Edit. Just hit, it's going to be on Edit automatically, hit Enter. And then you can clear out your columns here, go up to the top where the L1 is, and then just hit Clear, and then Enter. And that'll clear that one out. And then I can put my values in here, 68, same thing, down arrow or Enter to enter that. 196, 378, 262, 232, 377, 332, 225, 246. Does that say 0? I think it does, so like an outlier there. All right. So now I want to calculate the mean, median, mode, blah, 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 blah. So I'm going to go to Stat, and then instead of going to Edit, I'm going to go over 1. Notice that I put my values in that L1 column, so that's something I need to know. And then I'm going to do 1 variable stats, and so it says 1 variable stats, and then it's blinking, and what that's asking you is what column should we look at. And so the columns you can see here above the numbers L1, L2, L3, L4, L5, and L6. Since ours was in L1, I want that one, and it's blue, so I want to do second one. And that tells me, okay, we're going to do this, we're going to do these calculations for that first column. And then hit Enter, and then it gives you the stuff that you need, including the mean, the number of data that we had, and then we have a minimum given, and the median, which is something they asked for, and the maximum. You subtract 378 minus 0 to find your mid-range, right? So we can have all the same things that we had here. We'll go through all that. It says, is there a duration time that's very unusual? Well, what is this? This is the duration time of the flights of a space shuttle, and if one of them is 0, what does that mean? I mean, to me, it means that one of them was scrapped and they never took that flight, right? So that's an unusual flight time, right? So let's see what number 5 is. Okay, listed below are the errors between the predicted temperatures and the actual temperatures of a certain city. Find the mean and median for each of the 2 samples. Do the means and medians indicate that the temperatures predicted 1 day in advance are more accurate than those predicted 5 days in advance? So to find the mean, median, modes, and so forth of everything on the top here, I'm going to put those numbers in and I'm going to calculate it. I could do that in L1, maybe the second one in L2, or I could just do them both in L1, do one, clear it, do the other one. So we want to find the mean in that for the so they're talking about, this is the actual predicted 1 day earlier, the mean difference between high and the predicted high 1 day earlier is, and that is taking the mean of all that. The median from all that is 1, the mean is 0.4. You can put it into your calculator and check it, 0, 1, 1, 1, 1, 3, 1, 2, -4, -2. So these are how far off they were. This day they were exactly right. They were up by 1, up by 1, up by 1. Here they were down by 4. And so the mean, median, and then they have the mean and median of the second one, which is 5 days earlier. So 5 days earlier they do this prediction. And they got it 0.2 degrees and 2 degrees mean and median. And so the question is, do the means and medians indicate that the temperatures predicted 1 day in advance are more accurate than those predicted 5 days in advance, as we might expect? Well, look at the difference. 1 day in advance, they were off by 0.4 degrees. 5 days in advance, they were off by 0.2 degrees. If you're a person going out in the world and playing in the sun, and it's off by 0.2 or 0.4 degrees, you're not really going to notice that difference. Like, oh, that 5-day forecast was off by 0.2 of a degree more. So I think the predicted and the 1 day and 5 days aren't different enough for us to really notice. Even 1 temperature degree for the median is not very different. So I would say no, it's pretty much right on the same. All right. So this is probably a very similar question. We have a single line data and an individual line. Waiting time in minutes of customers in a bank where all customers enter a single waiting line, and a bank where customers wait in individual lines at 3 different teller windows are listed below. Find the mean and median for each of the 2 samples, then compare the sets of the 2 results. So again, you're going to enter all the data from the first up here, and you're going to find the mean and the median. And then you're going to do the same thing for the second set of data. And again, you're using your calculator, the 84 or the 36X or whatever calculator that you have. And then you're going to do it for the second column. And then once you get those 2, it's going to ask you to answer a question that uses your brain and your logical sense, whether the different times are different or pretty much the same. Now I'm remembering why these all look so familiar. As I worked this out, and the computer didn't record it, so I recorded the whole thing, but then it just deleted it. So that's why I'm doing it again. It's all coming back to me now. I'm very sad about that. Okay, so here's my data set for this one. Refer to the data set of times required for an airplane to taxi out for takeoff listed below. Find the mean and median. How is it helpful to find the mean? So here's a bunch of data that you have to enter. So I'm not doing that, but you get to do that. And so when you enter all that, then you go back and find the median and the mean. And they're kind of saying, why would you want to do that? So if you're wanting to know how long it's taking, because you are going to plan your flights around how much time it takes them to taxi and get off, if you don't want to schedule too little or too much time in there. So it's important to find things out like that for companies. It saves them money, and then they don't have angry customers waiting because it took a lot longer to do that than they thought, right? All right, so let's go on to number 8. Number 8 says, find the mean of the data summarized in the given frequency distribution and compare the computed mean to the actual mean of 57.1 degrees. Okay, so here's what you have to do when you have a frequency distribution is you have to find the midpoint of each of these categories. The only way you can do it. So we add 40 plus 44, you get 84, and you divide by 2 and you get 42. So the mid-range or the midpoint of each of these is given down here. I wrote those in. Again, add the 2 together, divide by 2, that's going to give you that. And now we want to go in and find out what the mean is for that frequency distribution. When I want to find the mean, I'm entering those midpoints. So I'm going to do that on the TI-36 first. Let me turn this on. I'm going to hit on, clear, clear. It's just going to get rid of my data so I have a clear slate. And now what I'm going to do is enter my midpoints, 42, 47, 52, 57, and 62. Okay, so now that was 5 different categories. Now I'm going to jump over to the right using my right arrow. I'm going to go over to the next column. And I'm going to put the frequencies that go with that. So with the 42 was 1, 47 was 4, 52 was 10, 57 was 7, and 62 was 2. And now I've got my things matched up. It's important that you put them in the right order. Now when I go data, whoops, I don't want to do that. I go second function data, in the wrong calculator here. I'm going to go down to one variable stats again and hit enter. But now it's going to say, where's your data, which we just saw. I put those midpoints in number 1, and it says then, where's your frequencies? Our frequencies aren't 1 for this problem. We have 1, 4, 10, 7, 2. So I do want to tell it, oh yeah, I put frequencies, which is the next column down here, I put those in L2. It's not enough just to blink on it. You have to hit enter so that it's showing me now. My data is in L1 and my frequencies are in L2. Now I can hit calculate. And it gives me a mean of 53. Why did I have 52 from before? And that's a little frightening that I got something different. But I would round to 53 in this case. I've got 24 pieces of data. How can that? I only had 5 categories. Add these up. 9, 19, 24. I've got 24 when I add up all the frequencies, right? And I'm pretty confident that I did this right, but who knows? I might have done it wrong. But anyway, I got 52, 53. You got the process. If you're on this calculator, I'm going to clear that by going up, hitting clear, and enter. And I'm going to enter these. We'll see which one, if I get the same answer, 42, 47, 52, 57, and 62. And then I'm going to go to the right with my right arrow, and I'm going to enter 1, 4, 10, 7, and 2. And then I'm going to go to Stat, Calculate. I'm going to do one variable statistics. And I'm going to say my data was in L1, so second 1, comma, my frequency, actually I haven't done this for a while, I hope this is what I'm doing right. Second function L2, and then hit enter. And that tells me that, tells it that I had the data in L1 and I had the frequencies in L2. And we got the same answer this time, which was 53. So now I feel pretty confident that last time I somehow went brain dead when I did that. So 53.0 is what I believe it to be. All right, so that's how you do that. And which following best describes the relationship between the commuted mean and the actual mean? You see where it shows the actual mean is 57.1 and we got 53. The computed mean is not close to the actual mean because the difference is more than 5%. If we're more than 5% off, we say like not too great then actually. Okay. Number 9, let's jump up and look at number 9 over here so we don't ruin it. I think my answer is showing. Oh, I did it here too. Oh, try it again. Okay. Number 9, methods used that summarize or describe characteristics of data are called. Well, we're describing, so what do you think of those choices? It is descriptive. So it's descriptive statistics that describes. Okay, that makes sense. Number 10, a value at the center or middle of a data set is called a measure of center. We have center, we have spread, we have frequency, we have different measures, but the measure of center is the center or middle of the data. That should make sense. It seems to make sense to me anyway. And you can always read what they have to say about that. Mean, median, mode, mid-range, those are all measures of center, which has their values. What is the, which is not a measure of center? Center is mean, median, mode, mid-range, not census. We didn't even talk about that. Let you read that on your own. Okay, which of these is not a characteristic of the mean? Well, the mean is pretty reliable. That's why you talk about it all the time. People talk about the average or the mean because it's pretty reliable. So I like that one. It is sensitive to outliers. That means that if we have a bunch of data, let's say TV personality, a bunch of people working on TV shows, and they all, one of them are making 50,000, making 70,000, making 20,000, whatever. But then we get Judge Judy to come along, and she's making, I really think I read, she's making like 35 million a year or something. It might be higher, but it was at least 35 million. And you put her in there and you find the average, then she is going to way throw off that mean, right? So that's means it's sensitive to those kind of outliers. The mean is called the average by statisticians. No, people call it the average on day-to-day Joes like us, but statisticians do not call it the average. And the mean takes every data value into account, which it does. We include them all. So it's this thing about what it's called by statisticians. That's the answer. All right, which of the following is always true? The mean and median should be used to identify the shape of the distribution. Not really. The mean and median are used to find the center of a distribution. Data skewed to the right have a longer left tail. No, because if it's skewed to the right, that means there's a tail to the right. Right, right, left, left, left tail, left, left skewed. For skewed data, the mode is further out in the longer tail than the median. No. And then in a symmetric distribution, the mean, median, and mode are the same. Yeah, if it's actually symmetric, you're going to find that those three measures of center are the same. That's nice when that happens. They don't always happen that way, but that's the one we're looking for there. All right, the symbols used for standard deviation: population standard deviation, sample variance, population variance. I mean, I can show you the answers, but then you just have them. But I mean, it's not that hard for you to find it. But when we want to talk about sample standard deviation, that's the S. When we want to talk about population standard deviation, we use the sigma. And then the sample variance is the square of the sample standard deviation, so that's where we get the S squared. And this population variance is the square of the population standard deviation, so that's pretty straightforward. I missed some of this. Listed below are the top 10 annual salaries of TV personalities. Find the range, variance, and standard deviation for the given data sample. Given that these are the top 10 salaries, do we know anything about the variation of salaries? So, once again, we don't know, and we only look at things like that. We don't really get a good sense of what everybody's doing when we look at just the top performers. So, that's something that should be clear by now. Where are we at here? This is number 15. Okay, number 15. Let's do this on our calculators. First of all, the range is the first one they asked for, and the range is just the subtract the greatest from the lowest in millions. That's something we can do easy enough. I did it over here. Let's see, I do it again. 24.2. How could I have gotten that? Well, the highest looks like 41 and the lowest is 16.8. So just subtract that and you get the range of the data. That's pretty simple. The variance we're going to use the calculator to do. And I'm going to use this one. But in both cases, you're going to find your standard deviation, and then you're going to take it to the second power to find your variation. So the standard deviation is given, and then we're going to take that to the second power. But let's do this. I'm going to clear this first one and enter this data: 41, 40, 39, 33, 22, 20, 19, 18, 17.6, and 16.7. This one has been sorted for us. Do you see how that's true? But I could sort this. If I go to Stat and go down to Sort A, if it wasn't in order, I could go Enter and then tell it, okay, I want you to sort the data that's in L1, and it'll put it in order. Sometimes that's pretty useful. And it just says done. Now when I go back in there and look at it, I've got it from least to greatest. It just always puts it from least to greatest, but you can sort it. You want to be careful you don't sort when you have it matched up to something to the right, because you need to keep those matched for a reason. Anyway, so that's just a little sort sample that I don't know of the sort sample on 36X Pro. Maybe you could Google it and let me know, but I don't think there is. I've not seen it, and I haven't had anybody tell me, which usually they do. So we would take 41 minus 16.7 here to find the range. I'll let you do that on your own. But let's go back and find the standard deviation that will calculate L1. And you're going to see a few things here, but what we're going to look for is the standard deviation here. This is sample. And so our standard deviation is 10.31, let's say. Yeah, okay, we will, because it's 10.31. And then I'm going to get, since they have you rounded two places, then you get the variance, we're going to take 10.31 to the second power. And that's how I got 106.30. So whatever you get for the sample standard deviation, you just take it to the second power. And then this is not a good estimation, because again, people are not realistic. I got 10.3, but they got 103.34. 10.31. let's see. We got 10.3122. Let's see. 10.3122 to the second power is 106.34. 10.31 to the second power is 106.30. Well, I hope they accept both. But anyways, if you don't get it right the first time, put a couple more decimals on there. All right. Okay. Number 16, I think, is the same thing, so I won't do it again. But if you want to see the answers to that, 55.0, 308.6, 17.6, well, I'll just leave them uncovered. But they want you to find the range, and you're just going to subtract, so that's where the 55 comes from. It says 1 decimal place, and that's why they have that. And then the variance and the standard deviation, you're going to do what we just did. Find the S of X. Remember, you're looking for the sample, so on the calculator, it's going to have the S of X. If it was population, the population standard deviation would look like that on your calculator, right? So then once you get that, you can take it to the second power. Why does that have a little squared on the end of it? I don't know. But anyway, same deal as 15. I'm not going to go through it again. I want to keep these videos so you don't be falling asleep while you're doing them. And number 17 is the same. We have to find the range. We have all these things. We have to find the variance, and we have to find the standard deviation of that. And you can pause it if you want and write those answers down and practice it, but I would just practice it on your homework. That's where you're going to have to do it anyway. And remember, all these homework questions could potentially show up on a quiz, and then all the quiz questions could potentially show up on your midterm and on your final, and that I will just reassure you if I haven't done that before. So I'm not here to trick you. I want you to know this stuff and not enough to be able to do it, but I'm not trying to throw curveballs at you for the midterm and the final. So what I do is I give you homework, and of those homework questions, I pick some of those to put on the quizzes. And then of those quiz questions, I pick some of those to put on the midterm. So if you went through and studied all the quizzes and knew everything on the quiz, that would be good to know for what you need for the midterm. You get 4 pieces of paper for the midterm, front and back, whatever you can hand write, nothing but handwritten stuff. So as you prepare for the midterm, it makes sense to go through and write down all your quiz questions and write out in detail, and then you have all the potential questions. And I've given you a practice midterm, I think, too, so you can see that practice midterm isn't for points, but it's just a chance for you to try and see how you do on it. So you have all your quiz notes written down, and then try that and see how you do. Okay. Number 18, man, I really was into these, so I did another one of those. You've got the range, the variance, standard deviation. It's a matter of punching into your calculator and doing it, so it shouldn't take you long, but why I did so many, I don't know. Oh, another one for number 19. Well, there you go. So number 19, they're asking to round to 3 decimal places, so part of it is reading the information that they give you and following directions. So you're going to find the range, then you're going to find the standard deviation and square that to get the standard deviation to variance. And then, just in case you haven't had enough, there's one more of those: range, standard deviation, and variation. And then you're going to answer questions about those in each case. So I think you're ready to go out and be fruitful on this one. Out of 20 questions, I think we're going to be fine on all that, and I'm about to do the homework for the video for 3B. All right, have a great day. I'll see you next time.